Show that for all k an element of R, the point 4k minus 2, comma 3k plus 1 lies on the line 3x minus 4y plus 10 equals 0. So here is the graph of the line L1. P is a general point on the line, can be anywhere, as indicated by these arrows, could be up here or could be down here. If P is a point on the line, then it must satisfy the equation of the line. So to show that a point is on the line, we just plug the point into the equation of the line and to see if it satisfies the equation. So we replace x in the equation with 4k minus 2 and we replace y with 3k plus 1. So here is the left hand side of the equation, and we just simplify all of this down and hopefully we'll get the right hand side, which is 0. Well, the k terms cancel out, we end up getting minus 10 plus 10, which is indeed 0. So that shows that P is on the line. P is on the line, which is called L1. We could call this point the parametric form of a general point on the line L1. So by plugging in any number we like for k, we can generate a point on this line. So k is any real number. The line L2 passes through the point P and is perpendicular to L1. Find the equation of L2 in terms of k. Here is a rough picture of L2. To get the equation of L2, we have to get the slope of L2. To get the slope of L2, we have to get the slope of L1. So how do we get the slope of L1? Well, we have the equation of L1 up here. We have to write the equation of L1 in the form y equals mx plus c. In this form, the coefficient of x is the slope. So let's do that. So we rearrange this equation to make y the subject. So if we make the y term the subject, we have minus 4y equals minus 3x minus 10. We divide across by minus 4. We get y equals 3/4 x plus 5 over 2. So we see that the slope of L1 is 3/4. Because L2 is perpendicular to L1, we get the slope of L2 by inverting the slope of L1 and changing the sign. So we see that L1 has a positive slope, slope of plus 3/4. L2 has a negative slope, slope of minus 4/3. Now, we have the slope of L2 and we have a point in L2, that's the point P. That's enough information to fully specify the line L2. So now we can get the equation of L2. We use the formula y minus y1 equals m times x minus x1, where x1, y1 is a point on the line L2. So x1, y1 is the point P in this case. That's the only point we're given. So we have y minus y1, y minus 3k minus 1 equals m, which is minus 4/3 times x minus x1. So we want to minus this, so we get x minus 4k plus 2. We normally like to get rid of fractions, so we multiply both sides by the denominator of m. We multiply both. Multiplying this by 3, we get 3y minus 9k minus 3. If we multiply the right hand side by 3, we get rid of this 3, and we're left at minus 4 into this bracket here, which is minus 4x plus 16k minus 8. Now we can bring everything to one side, and we just have 0 on the right hand side. So we have 3y plus 4x. If we bring the plus 16 over, we get minus 9 minus 16 is minus 25k. And we have minus 3 plus 8 is plus 5. And we just have 0 on the right hand side. So here is the equation of L2. We can see that unlike L1, L2 involves k. Find the value of k for which L2 passes through the point Q, which is coordinates 3, 11. Q is actually shown on the diagram. Here is point Q, its coordinates are 3, 11. So we want to find the value of k for which L2 passes through this point. L2 is a line that's perpendicular to L1. P is a general point on the line actually. The coordinates of P depend on what k are. So we want the particular line that passes through the point Q. So L2 depends on what k is. You can see from the equation of L2 here, for different values of k we will have different lines L2, but they all have the property of being perpendicular to L1. So now we want the particular L2 that passes through the point 311. So we want 311 to be on this line. That means we want the point 311 to satisfy the equation of this line. So we plug 3 in for x, 11 in for y, and it must all work out to 0. From that equation we can find k. So if we do that and solve for k, we get k equals 2. So we can now actually write down the L2 that passes through the point Q. So we just plug 2 in for k, so we get 3y plus 4x minus 25 times 2 is minus 50, plus 5 is minus 45 equals 0. So we have the equation of the line that passes through the point Q and is perpendicular to L1. Hence, or otherwise, find the coordinates of the foot of the perpendicular from Q to L1. So we want to get the coordinates of this point here. Okay, there are two ways that we can do this question. We have the equation of the black line, L1. We can also get the equation of this line, as we saw, by setting k equals 2 in the general equation of a line that's perpendicular to L1. And when we set k equals 2, we get 3y plus 4x minus 45 equals 0. So this is the situation when k is 2. So it's just a matter of solving between these two equations. Simultaneous linear equations, something that we covered in algebra. It's quite straightforward to do. However, there is a much easier way. The general equation of this line is 3y plus 4x minus 25k plus 5 equals 0. The general coordinates of this point, that is where this line cuts L1, are 4k minus 2, 3k plus 1. For k equals 2, this line becomes 3y plus 4x minus 45 equals 0, and the intersection of this line with the black line is still given by this, of course, because this point is a point on this line. It has to have this form here, 4k minus 2, 3k plus 1. But you see that now we know that for this particular line, k is equal to 2. So the intersection of the lines is given by this general form with k replaced by 2. So we're going to have 4 times 2 minus 2, 3 times 2 plus 1. So we get 4 2s are 8 minus 2 is 6, and for the y value we get 3 2s are 6 plus 1 is 7. So our answer is 6, 7.